Hi friends, welcome. So we'll start the sessions today. Previously we have learnt about the loops and the if-else condition checking, while loop and for loop also. So what the best way to understand the concept or to learn is to do some practice, and that's what you will do it. Today we'll just practice some very simple applications, say how to take the factorial of a number or a prime numbers or a Fibonacci series and all, some of the digits. Of course, earlier we have already seen how a prime numbers can be generated up to 100, and you can extend it also. So we'll practice these sessions, and probably next week in the beginning, when you are thorough in this practice, we'll go for our user defined functions. So before we move, let's just once again my request is, please subscribe to our channel and press the bell icon, so you'll be notified as and when we are adding, and we are coming frequently online now, and we are uploading videos also. You'll be notified as and when we add that. So please subscribe and press that bell icon. So let's come to our browser. Here it is. These are the questions ready. Factorial of an input number, factors of an input number, prime numbers, Fibonacci series, sum of the digits of an input number. These are all small codes. We'll try to develop this. But before that, you just see here. Here is the URL. This URL is available in the description, and all these links are there. So you scroll down. Here is the GitHub link. Click this GitHub link. So you will be taken to GitHub, and you can download the .py files, whatever is there, and or in Jupyter Notebook also you can download and open in Colab. So this, if you click, you will be taken to your Colab platform, and you can test all the script. You can save, download. Colab is the Google's cloud Python, ready to with all the functions whatever you will be using, and it is available for ready to use. It's a Colab platform, so no need to install anything in your system. So here we are. Now let's start it. So first we'll say, what are the factorials of a number? Okay, this is two parts of it: input number by looping and by recursive function. Recursive functions will wait, because the same notebook will extend when you finish the user defined function. So recursive function will add to this. So now at present we'll do by using whatever if else and loops whatever we have seen. So we'll start from here. So what's a factorial, by the way? It is the product of all the integers from 1 till the number, including the number itself. Say factorial of 5 is 1 multiplied by 2 multiplied by 3 multiplied by 4 multiplied by 5 also. So that's the factorial. So that we'll see. So we'll first start with asking for an input number. So A is the number here, or you can give a better variable, but this is a small code, so we are using A, B, C, D, X, Y, Z like that. So as we know, we must use the input, enter a number. I'm just fine. Now what happened? This input will take the number from the user. Why I am using int here is, any number, even if I enter 10 also, it will be treated as a string. So I must convert it to an integer. So I have written, now A will hold, if I have entered 10, then A will hold the integer 10, not the string 10. So that is the purpose. Now B equal to 1, fine. For I in range starts from 1 till A plus 1. Why we are adding 1? As we have discussed before also, the range function will, this is my stop number, A plus 1. Suppose I have entered 10, then this will be 11. That means it will stop 1 before. So it will stop at 10. So I want that if I am input my 10 also should be multiplied with 9. So in that is why I am taking it 1 ahead. So it will stop at that. Now I will say B equal to B multiplied by I. Sorry. Here I here I mistake. For I in range, B multiplied by I. That's all. Now I will print the result. Print little factorial equal to, now I will say B. B is the factorial here. So multiplying each one next one like that, I am multiplying. So let's just run this. It will take bit time because it's the first time I am running this file. So it will connect it, allocate the resources, Colab, do that. But Colab is easy to share, and anyway whatever ID you are using you can use it also. You can download. Here you will get a download link here, file, download link, download IPYN by .py. Fine, now our script has entered. Now let me give a number as 6. So 720 is the factorial of 6. Now once again let me run. Let's say 10. Okay, this is the factorial of the number. Now we can do the same thing by using recursive functions also, but that we right now will not use, because probably tomorrow or next week we'll learn about user defined functions, then we'll use the recursive. Okay, so this part is over. Now let's go back a bit. Work on what is the next factors of an input number. What is the factor, by the way? Let's just see that. Factors are number which are divided the number evenly. Divide the number evenly. Say I am thinking, let's for example it is 6. So what happened? 2, 3, these are the numbers which divide it evenly. Means if I divide, I get a remainder of 0. That's the logic we'll use. So factors are, these are the factors. So what is the highest? You must have read the highest common factor, lowest common factor, all those things. So factors of an input number, we'll again ask the users to give an input, and we'll find out what are the factors. As simple as that. It is, you just suppose user enters 10, then what you will do, will start from 1 or 2, whatever you will start, and then you will see it's divisible like that. Then you will start with 3, then you will 4, like that it will say. And if it is divisible means we will be checking the remainder. If it remainder is 0, then it is a factor. Then we will check the next number. If it is remainder is 0, then it's a factor. If it is not, it is not a factor. Then we will just simply print out. So let's just fine. Now n. Okay, anything you can take. Again integer. Now I am saying input. Sorry. Enter a number. So here user will enter a number. I am converting into integer and storing it as n. Variable n will hold 10, 20, whatever the user has entered. Now what I am going to do is, or directly I can take something number also. For I in range 1 to n plus 1. Okay, because the stop word is there. But here is the thing. We have already discussed, we need not check till the number, say up to one digit we are checking. If the input number is 10, we need not check up to 6, 7, 8, 9, 10, because half of the number, whatever is there, from beyond the half the number, there can't be any factor, because nowhere the remainder will be 0. Just think, if an input number is say 20, then up to 10 only the reminders will be there. The remainder will be 0. Beyond that, never the remainder will be 0. So for a simplicity, we are just using like this. Then we will come back. For I in range, I have to put, if. Now here you just see n divided by this is the modulus operation. Modulus is, this operation will gives me the remainder of the division. If I am dividing n with I will get a remainder. Now that I am comparing with this is a comparison operator, not equal to. Single equal to means I am assigning the value, n takes the value. This is 2 equal to means it's a comparison operator. If it is equal to 0, then that means that is a factor, because it is divisible. That current position value of I is divisible by n, so it's a factor of n. So that's what I will print out. Print I, the value which is divisible I, and what I am doing, I am to the right of it, I am putting a comma. I am not allowing any line break. So vertically I am not giving. I am giving next number will be right of it, next number will be right. So I am giving end equal to 1 comma I am putting. So this will remove the line break and print a comma after the value. So input a number. Fine. Let's just see. Say I am giving 10. 1, 2, 5, 10. So you say why you are putting 1 here. So let's just start from 2 and 10 is there. So 2. So 10 should not be, because okay, what is the definition says? Definition says factor numbers divided by the number evenly. 0 as a reminder. Okay, so otherwise you can just up to 9. But here again n by 2. Now here I will say int, integer n by 2. Okay, now what happens? I need not check till the last beyond the half the value. So let me just run this. Let's give 20, 2, 4, 5. Fine, correct. Let me again. Sorry, I can. Why 10 is not there? So what happens if 2n by this here? I must give a plus 1. Let's see again the. Yeah. Why? Because n plus 1 means if it stops at 9. Suppose if it stops, because if that means in case of 20 it is 10. So it stops at 9. So no, let it one more step it go. So that is why it is number 20. So the factorials are 2, 4, 5 and 10. So this is the factorial part. Experiment this. Then prime numbers. I will not. Do you want me to? Let me know, because last for 2 days for while working on the for loop and working on the while loop also, prime numbers we have discussed. So those who have not joined before, for them let me quickly go through the prime numbers. It's same thing, but it required little. Let me just copy that. I will not take. I have the script here. What's a prime number, by the way? Okay, list out all the prime numbers. So 3, 7, 13, all these are prime numbers. So up to 50 I am asking. So here I have taken change this value 50. Let's see. So 2, 3, 5, 7, 11, 13, 17 up to 47 prime, because I have upper limit. If I will increase this to 100, this we have discussed for last 3-4 days. We are almost discussing this. So 2, 3, 5, 7. Okay, let me just explain it. For I in range 2 into n plus 1, I have taken up to 100 value. Flag is 0. If j in range, another, this is a nested loop. So for it, in fact, you can go for while loop also. So for j in range 2, the same concept. If what happens is, I am just checking, say I am picking up to 50 means 1 by 1 all numbers I am taking. I am taking the value, say I have taken 8. So what I am trying to do, I am starting from 2, I am going 2, then 8 divided by 2. Next is 8 divided by 3. Next is 8 divided by 4. Anywhere, if I encountering this division is remainder is 0, that means that is not a prime number. So here you can see the break will throw it out of the loop and print the end value. So a better way also we have by using while loop also we have done this. So leave this part, you can copy the code. Yesterday, day before also we have discussed this. Fine, now let me just come back. I will at the end, the other while loop and for whatever we have used, that also I will paste it here, so you can use it when you download this source code. So Fibonacci series, what's the Fibonacci series? By the way, it is a number. Each number is the sum of the two preceding number. So a series is 0, 1, 1, 2, 3, 5, 8. So you any previous number you add up, the next number will come. That's a Fibonacci series. So how I will get that one? Fine, let's start here. What's the time? Yeah. So n equal to 15. Say how many numbers are required? That is the figure here. N is equal to 15. I have to put a counter. I equal to 0. Now first initially I have to start 1. N1 equal to 1. Now N2. These are variables I am setting. N2 equal to, let's say, 0. While here the condition is, here I is less than n. What is the meaning of this? n is 15. I am generating Fibonacci series up to 15 numbers. 15, the series will have 15 elements. So for that I am telling, I have put a counter, I should not exceed that. That's why this condition is. So print n2 end equal to, this means there is no line break here. Sorry, or I will put a comma here. Line break is not there anyway. I have put a comma. So to the right of it, next number to the right of it, it will continue. And moreover, this 1 by 1 and a comma is there in between these two. So that is what. Now I am creating a temp variable. Temp variable is equal to n1 plus n2. That is the one. Now n1 equal to n2. Now I am swapping these numbers. Then n2 equal to temp. Okay. Then I am increasing the I equal to I plus, sorry, I equal to I plus 1. I am increasing it. Now fine. So here what has happened is, I will move up a bit. Yeah. See here, print n2. N2 first it will print 0. Now temp is n1 plus n2 is this is the sum of this n1 n2. Initially we have taken 1, so it's 1. Now I am just swapping the number and n2 is taking the next sum of it. So like that, 2 digits I am printing, then the sum of these 2 I am keeping a third, then I am shifting it to next one. So the second one and the third one, both I am summing and printing it as the fourth one. So for that I am using a temp. This line actually, when we are discussed about variables, for the simplicity, everything one by step we are writing, but you can bring it to one line. I will put that code also. So let's just first check this. Okay, here is the, let me just up to 15 numbers are there. If I will increase this, I will get some more digits. Let's say 20. Okay, up to 20 elements I am printing. This is your Fibonacci series. So slightly further improvements will do and put that also. So let's go back. What next? Sum of digits of an input number. This is, there are 2-3 ways of doing it. Say a user has entered say 112. So 1, 1, 2. You have to sum 1 plus 1 plus 2. So you have to print 4. Whatever the number the user enters, you have to print by summing the digits, each digit. So what the concept here is, pick up the each digit from the number, then sum it up and print it. This further we will see what is the significance of this, but today we will see only the sum of this one. So sum of digit of one number. With this we will close this. There are many other scripts are also there. We will continue further. Okay, the easiest way first. We know, we have so far discussed, any number you enter, it's treated as a string, not as an integer. Then we use int to convert it into a integer. So for that purpose, n equal to input, enter a number. They are asking user to enter a number. Now here, just understand one thing. When the user enters, it's not an integer, it's a string. So in string, all strings are iterable. It's like a list. Let's just try one thing. Print n1, 0, 1, 2 like that. Suppose, imagine I am 3-digit number I have entered. The middle digit I am trying to. Let's just see how it works. Enter a number. Suppose 879 I have it. See, it has printed me 7. The 8 is 0th number, 7 is the 1 number, 9 is the 2 number. So here this prints the middle number because 1 I have given. Now this is why it is not a 879. It is a string which consists of 3 elements, because a string is a iterable object. We will also study what's a iterable and all. So we can pick up each one by 0, 1, 2, 3 like that. So let me just comment this line. Fine. So once I have the elements, I have nothing more to do, just loop it that. So for I in range starts from 0 till len n. What is len? len is the length function. It counts the number of element. So here if I am 879 means the len will have a value of 3 because there are 3 things are there, n is there. So what I am doing is, again I did a mistake, for I in range. Okay, for I in range 0 means first loop I will take the value of 0, then 1, then 2, 0, 1, 2. That's all. It will not go. If I am entered 3-digit number, if I have entered 4-digit number, because this value of len will depend on how many digit number I have entered. If it is suppose 445, 3-digit, 1080, 4-digit number. So that this value will change based on the number of digits I have in my input number. Fine. Now I will sum it. Sum equal to, initially I have not initialized sum. So here I will say sum equal to 0. Oh, sorry, this better, as we decided my sum. We will not use sum because sum is a built-in function. So I will say my sum. This we have discussed why you should not use it. There will be a conflict and it will be confusing also. So my sum, fine, my sum equal to single equal to, because here I am assigning, I am not comparing two things. My sum plus, you may say that I will n, but here n inside I. So first time 0, second time 1, next time 2, like that it will take. So you may ask me like that, but there is a issue here. This will generate an error because my sum is a integer and this is a string, because n0, even the first one also, because we have taken it as a input as a string, we are not converted into integer. Now for this sum I must convert it to an integer. Fine. Now print it. Hope this logic is correct. Let's just run this. Enter a number. I am telling say 45 or 54. Okay. 5 plus 4, 9. Okay. Once again, I will digit a 4-digit number. I will enter 1, 2, 3, 4. Okay. 1234. I mean. It is 3 plus 4. Yeah. So this gives me the sum of the individual digits. There are some better way of doing this also. Little confusing, but let's try. What is the way is, this is a simpler way because you get a string, that's why we know each character we can pick up from the string. So here a number, if you take it, if you divide it by 10, the remainder is the last digit always and the quotient is the previous 3 digits. Say this is 1, 2, 3, 4. Say this, let me move up a bit. 1, 2, 3, 4. If I divide it by 10, I will get the last digit as the remainder. And next 1, 2, 3, again I will take it and divide it by 10 again. 3 I will get is as remainder. Again 12 I will take. 12 is the quotient or the floor value of the division. Every division will get two things, either quotient or the floor value and the remainder. So all remainders gives me the digits and all floor value will give me the what next I have to divide. That's what. So that logic we can apply and get the sum of the thing. Though this is very simple, but still better for our learning purpose, why we should not try. So here I am directly, whatever the input it is, I am directly taking it as not as a integer, not as a string. So I must use it as a integer. So int, because here my purpose is, otherwise my division won't work. Now sum equal to 0. Sorry, again I have to use my sum, not sum. My sum equal to 0. Fine. Now while n is greater than 0. What is n? This is the number, what is input number. So and it's a integer, not a string anymore. I equal to n I equal to n modulus 10. So I is the remainder. I got the first digit is I. Now what happened? The sum, my sum equal to my sum plus I. Is it clear? Because the I will be the reminder when I divide. Say example 1, 2, 3, 4 I have entered. So the once I divide this number n by 10, I am doing it. So n by 10 means reminder will be 4. 1, 2, 3, 4 divided by 10 is 4. So that I am adding to my sum. But next what I am going, n I am replacing. N equal to n. This is the symbol what is used for getting the quotient or the floor value. I will write it in the comment, floor value. Value or percent. So this is the, now the n is not, suppose 1, 2, 3, 4 I have entered. Now it is not at this stage, it is 1, 2, 3 only. Last digit, as if I am removing the 1 digit from it. So that is the concept here. Now I will come out of this. It will come out of the leaf once the last digit is divided by 10. So it is no more a greater than 0. So what I will do, print sum of the, okay, whatever you want to write. Now let's just see. Again I will enter 1, 2, 3, 4. Sum of the digit is 10. So this is another way of doing it. So that's also, there are few more scripts. We will continue on this page itself. So we will extend it further. You can just check this one, and I will write the comments here so you can easily understand this, like this floor value or percent, like that, get the reminder. I'll fill all the information here, and you can download this entire Jupyter notebook and download. As I told you, you can download it, download here, download as .py file also, IPYNB, and from the Colab we have seen how to come here. That's all, friends. Again tomorrow we'll balance some scripts are there, we'll try those things. So further in this page itself will continue. And before we conclude, my request is please subscribe to our channel and press the bell icon, so you'll be always getting the notifications. And if you have any ideas, suggestions, questions, okay, Rusikesh Dongre, okay, thank you Rusikesh for liking this. So if you have any doubts, suggestions, questions, please use the comment section below to post it. And once again my request is please subscribe to our channel and press the bell icon, so you'll be notified always. And if you have any friends, please share this with them. Thank you for watching.